Welcome to Peru Tech Future Vision YouTube channel.
I am Dr. R Perumal, Professor of Petrochemical Engineering, JCT College of Engineering and Technology, Coimbatore. In this video, we will discuss about some two more questions in process dynamics and control. The first one is a problem. Write down the Laplace transform of f of t equal to e power minus 2t sine 3t. So this is an input function. We have to write the Laplace transform for this function. First we have to write the equation in the standard form. The standard form, the equation is written as f of t equal to e power minus at sine kt. The Laplace transform for this standard equation is f of s equal to k divided by s plus a whole square plus k square. Here a equal to 2, k equal to 3. Substitute the value for a and k. We will get the transform equation 3 by s plus 2 whole square plus 3 square. This is the given transform for the equation. Next one is define open loop system. So we are driving a car. The speed of the car is measured by the speedometer. The speedometer indicates the speed of the car, but it's not going to alter the accelerator to adjust the speed. The adjustment will be done by manually. So this system is called open loop system. In an open loop system, output is not feedback to the system for any manipulation or comparison. So output is only to read only. We are not going to use the output for any manipulation or comparison. This system is called open loop system. Now let us consider the mercury thermometer used to measure the temperature of a water bath. The mercury thermometer is placed in the water bath. As soon as you start applying the heat to the water bath, the heat will transfer from the liquid to the mercury through an interface. So this interface is called as a film. Now the resistance offered to the flow of the heat lies within the interface only. We are not going to consider the resistance offered by the glass and mercury. All the resistance, we are assuming all the resistance lies within the film surrounded by the thermometer. This resistance depends upon the heat transfer coefficient of the film and the cross-sectional area of the film. So the product of the cross-sectional area and heat transfer coefficient is called resistance. The next heat is reaches the mercury. The mercury start expanding. The rate at which the mercury is expanding depends upon the mass of the mercury and the heat capacity of the mercury. Here also we can assume all the heat capacity lies only within mercury. This mercury expansion, also we can assume the expansion of the mercury is considered here. We are not going to consider the expansion of the glass wall. With these three assumptions, a thermometer is used to measure the temperature. Before applying heat input to the system, the temperature indicated by the thermometer is called as steady state temperature. At steady state, the temperature input to the thermometer and output from the thermometer is equal to same. That is, input temperature is equal to output temperature at a steady state. At any instance of time t, the temperature given by the thermometer is called as output temperature, that is response. The temperature applied to the thermometer is called input temperature. If you want to note down the deviation of the output temperature and input temperature, if we denote steady state temperature is x of s at input, at output it is y of s. The output response is given as y, the input is x. The deviation in the input can be calculated as x. Deviation equal to temperature at any given time minus steady state temperature, that is x minus xx. Similarly, the output temperature, the deviation in the output temperature y equal to temperature at any given time minus steady state temperature. That is, the deviation is equal to y minus ys, deviation in the input equal to x minus xs. If we take the Laplace transform for these deviation variables, the deviation Laplace transform of response we can say y of s, the Laplace transform of input we can say x of s, the ratio between the input to output to the Laplace transform of these two deviation variable is called as transfer function. Then next, when you apply the heat, the thermometer will take some time to respond the input. This time is called as time constant of the thermometer. This time constant depends upon the resistance offered by the film and the capacitance of the thermometer. Here capacitance is the product of the mass of the mercury and the heat capacity of the mercury. So with this concept, now we can see what are the questions we can ask. Define transfer function and explain its properties. The transfer function relates two variables in a physical process. We can see one input function is there, one output function is there. The input is called as cause and output is the effect. The Laplace transform of input function and the Laplace transform of output function in the form of deviation variable we can calculate. The ratio between the Laplace transform of input deviation variable to the Laplace transform of output deviation variable is called as transfer function. There is a transfer function g of s equal to y of s divided by x of s. Here y of s is the Laplace transform of the output deviation variable. X of s equal to Laplace transform of the input deviation variable. The next, define a first order system. So we know what is a transfer function. So transfer function is the ratio of the Laplace transform of input to the output. Here we know that what is time constant. Time constant is the product of resistance and capacitance. So any system which obeys y of s by x of s equal to 1 by tau s plus 1 is called as steady first order system. Any physical system for which the relation between Laplace transform of input and output deviation variable is of the form y of s by x of s equal to 1 by tau s plus 1 is called first order system. Here tau is the time constant. What are the assumptions used in developing a transfer function for the thermometer? In the thermometer we have made three assumptions. First one is that all the heat transfer resistance lies within the film surrounding the bulb. The resistance offered by the glass and mercury is neglected. So all the thermal capacity is in the mercury. Furthermore, at any instant the mercury assumes a uniform temperature throughout. Then third assumption is the glass wall containing the mercury does not expand or contract during the transient response. So these are the three assumptions which we made to measure the temperature using a thermometer. So list out different forcing functions. The input function or the cause can be classified into step function, impulse function, sinusoidal function, and one more is the ramp function. So step function, the input x of t equal to a into ut. The response is, so need not show the response. Then impulse function x of t equal to a into delta t. Sinusoidal input x of t equal to a sin omega t. So these are the three important input functions which we used in first order system. Give the response transform of step function and exponential function. For step function of magnitude a, the input function x of t equal to a into u of t. The transform is x of s equal to a by s. This is the step response and step input. For exponential function, x equal to 0 when t is less than 0, x equal to bt when t is greater than 0. The transform is x of s equal to b divided by s square. So write the units of resistance capacitance in a thermometer. So the resistance is heat transfer coefficient into cross sectional area, that is degree Kelvin second divided by kilojoules. Capacitance is the mass into heat capacity. as a SI unit kilojoule per degree Kelvin. Define resistance and capacitance of a first order system. So resistance is defined as the ratio of the change in driving force to the change in flow. So how much we are giving a change in the input and how the system responds, that is called resistance. Capacitance is defined as the ratio of the change in storage to the change in driving force. And explain the linearization of non-linear system. Generally most of the equations, most of the input functions will be in non-linear form, but to apply Laplace transform we have to convert the non-linear equation into linear form by using a Taylor series. By applying a Taylor series we have to convert the non-linear function into linear function, then we can apply the transform for that linear function. Thank you very much.